All right, so if on this side, in this pan, we had x plus 3. So think of x as like I like to think of it as like a bag. And inside the bag, we're labeling an x, and there's some things in the bag. I just don't know how many. And on this side, there is 7. What should x be? What does x need to be so that the pan is equal, the pan is exactly level, one side's not heavier in value than the other side. One side's not worth more than the other side. What would x be? You guys type it into the chat if you know. What should x be to make this equal? To make that not tip one way or the other, what should x be?
So nobody's typing into the chat yet.
Nobody type into the chat, or everybody type into the chat. What should x be? How many things need to be in this bag so that this side balances that side? What does x need to be? I'm not really looking at the chat, Mrs. Nelson.
You're good, Mrs. Brown. We have 2 people in. They did say it to everybody, which is fine. The answer is 4 is the most popular answer.
So 4 is the most popular answer. We'll put that down there. Let's take a look at another one then. And if we had, t minus 5. Again, I like to make my t's curvy so they don't get mistaken for the addition symbol. So if this was something in the bag, and I'm going to take away 5 of those somethings, what would that have to be? So that's 3, so that it's exactly the same value. So when both sides are done, they both have that value of 3. What would t have to be? Let me know when you have answers, Mrs. Nelson.
Okay, I've got 2 people participating.
Okay.
And the most popular answer is 8. So we can assume that everybody else doesn't know what to do.
Okay, so we're going to be explaining a little bit of thinking, looking for patterns and thinking about if that's true, what patterns, what are we trying to do?
And if it's algebra, we should put t equals 8.
Correct. So I'll do that. We are saying that the t would have to equal 8 for this to be true. And over here, we're saying that the x equals 4 to be true. How about this one? For y 28, what would y have to be true so that if I have 4 sets of it, it would be equal to 28? What would that have?
A little hard to see. I mean, you said what it was, but
4 times y and 28. Is that because I need to go this way a little bit?
That's good.
What would y have to be to make this true? To make it balanced, to make it so one side's not heavier than the other? Do you have an idea?
One answer in the chat, and it is 7.
Okay. All right. So if I thought about that, if I had 7 sets of 4, so if I had 4, 1, 2, 3, 4, 5, 6, 7, would that be 28? About that. All right, here's another one to try out. Another operation we are doing with the
That was my guess that it was going to be division.
Because we had an addition, we had a subtraction, we had a multiplication. What was left, the other operation must be division. So what would this need to be to make it true? What would W have to be so that this side is equal to 6 as well as that side?
Is it W divided by what?
2.
W divided by 2. Thank you.
Sorry, you really can't see it, huh? Let me scooch it over and try and push my music.
We're good. It's just, yeah. All right, and then so W, the top answer is 12.
What top number?
The top answer is 12. I mean, the answer that's being given the most.
Got you. W is 12. So if I put 12 in here, 12 divided by 2 is 6. So I can check your answers, and we can talk about what that is, and that's kind of leading into today is checking these answers. So if we do that, if I take x plus 3, and I think about, I like this balance symbol because when I like to check, we're checking to see that, is this a solution? I'm checking to see your work now. I want to see if that is a solution. And how it's a solution means that this should be true. I'm checking your book does this like question mark above it. Is it true?
So how did we get that answer? If you gave me the answer 4, how did you get that answer? Diego Parker, I need you to talk with me.
I'm checking if it's true, and I do see that that is true because on this side I get 7 and on this side I get 7. I can check it. How did you know that it was 4? What made you believe it was 4? What did you do?
How did you get that answer?
I can check that it's correct by substituting your answer in on this side, and then I see that it is 7. How did you know it was 4?
What I did was I did 7 minus 3 equals 4.
So you're thinking, so I'm going to put some thinking bubbles here because I love that you're sharing your thinking. Thank you for doing that as we're going to look for patterns. You did 7 minus 3, so you were thinking x has to be 7 minus 3, so x has to be 4. Diego, what did you do?
I did the same thing he said.
You did the same thing, okay?
So
So
the way that we solved that, and I did it the same way, right? We used the inverse operation, and we went ahead and we subtracted. If we were going to do it algebraically, we would show it that we subtracted 3 from both sides. So if I did x plus 3 minus 3 on the left side, that would leave me x all by itself. And then 7 minus 3 on the other side would leave me only 4 on the other side. So good job. How would we do the next one?
model that other one, the inverse operation, or you could do what we were just saying. Okay, I have x plus 3 over here. I want, what I would be thinking is I just want x. I don't want to know what x and 3 more is. How do I get rid of that 3 more? I'm going to take away 3. If I take away 3 from this side of the equation, I have to take away 3 here. So here, x plus 3, take away 3 leaves me with x. And on this side, 7 minus 3 is 4. All similar ways. Let's take a look at.
We're using absolute value there to put the variable by itself.
So let's take a look at this one. I want to check your work first. So the first thing I'm going to do is I'm going to substitute it on this side and see if I get the same answer. So what I would write is I would write t minus 5 equals 3, and then I would put 8. I'm doing a check. I want to see if it's true if I put in 8 minus 5. Is that true? And 8 minus 5 is 3, and 3 does equal 3. So that is the solution. How did you think of this one? What did you do? I know I can check your work when you told me, but if I didn't know what to check, what are you doing?
What I did was I did 5 plus 3 equals t.
Okay. Would it be, Parker, okay if I wrote it as t is 3 plus 5?
Yes.
Okay. Are these the same?
Yes.
Why? What property?
They are associated.
They travel.
Travel. When you travel, you commute. It is the commutative property.
Commutative property.
And the reason I wanted to write it that way is another way I would have looked at it is I would have said, okay, if t minus 5 is 3, I don't want to know a group of a bag with t things in that someone took 5 out. I want to have a bag of t things. So I want to put those 5 things back in. And if I put 5 things back in on this side of the equation, I have to put 5 things on this side or my balance isn't going to be equal. So this becomes t take away 5, but then I put them back in again. So I have t, and on this side it becomes 3 plus 5, which is 8. Another way to look at it.
And again, absolute value. We use absolute value to isolate the variable by itself. We do that if it was a fraction. We do that if it was a decimal. We would do that as the numbers get larger. We would do the same thing. So again, we use the inverse operation.
Inverse operation. Just circling what you were just saying. This problem had an addition sign, but to figure it out, we did subtraction. This problem had a subtraction sign. To figure it out, we did addition. Inverse, opposite, right? Okay. Let's take a look at this one. Let's check it first. So I'm checking. If I'm going to check, I'm going to see, okay, I want to see is, if y equals 7, is it a solution? So is it true that 4 times 7 is 28? I like the way your book does that. It's like question mark, is it true? So I'll look at one side, 4 times 7, 4 sets of 7. 7, 14, 21, 28. 28 on this side. It is true that 28 is equal to 28, so it is a solution. If it was, one side was a different constant than another, then it would not be a solution. Okay, can you share your thinking? What did you do on this one? How did you know to do 7?
I did 3 times 7 equals 21, and I know that 21 plus 7 equals 28.
So these little 3 dots mean therefore 4 times 7 is 28. Okay, so that would be a trial and error. Trying something, going to try one in, see if I got there. 4 times 3, okay, 4 times 7 is 28. So just trying some different things out until you hit it.
Diego, how did you do it?
I just knew that 4 times 7 equals 28.
Okay, good. So the reason we're practicing this is because what if those numbers were 411 and 22, right? So we need to work on a process of what's happening there. So that's good. That works here. What Mrs. Nelson did was she used the inverse operation. I said to myself, 28 divided by, I can't see the problem again because I can't remember, divided by 4 equals, I divided by 4. So it was a multiplied 4, so I divided by 4. I divided both sides by 4 to get 28.
So want to know what, not what 4 times y is. If I want to know what y is, divide by 4. If I divide this side by 4, I get y. Divide this side, I'll get 28.
So
Just,
all 3 of those ways will work on this problem.
so if we wanted to use the inverse, so same thing here. We can try that w. We can put it in, and we're going to check the solution. We want to see, is it true that 12 divided by 2, we want to know, is that true that that's 6? 12 divided by 2 is 6. 6 is equal to 6. Always is, always will be. So that is a solution. Once again, how did you solve this one? Who gave us the answer to be 12? How did you know it was 12?
I solved that one because I know, well, there's 2 ways I solved it. First, I did what is 6 times 2, and that equals 12. And then what I did was 12 divided by 2 also equals 6.
Oh, and then you checked it.
Right.
Sounds good. I like that you said that you used 2 strategies, because that's what we're always doing. If we're not, can't go look up the answers in the back of the book to see, then we're checking in another way. I really like that. So if we look here again, what we're doing, one way to find it is here there was division and here there was multiplication, right? It's invisible. Here there is division and here there is multiplication. So when we are solving for something, we're doing the opposite operation. If it was subtraction, we're going to add. If it was addition, we want to subtract. If it was multiplication, we want to divide. I think of it as like kind of like unwrapping a present. I want to undo it. We would say in math, I want to isolate the variable. So if I looked at this and we said W divided by 2 is 6, I don't want to know what half of W is, right? Because that's half. I want to know what a whole W is. So how do I make that whole? Well, I make that whole by dividing by 2. If I do it here, I have to do it here. So all of W is 12. And the reason we're looking for another way, these are all excellent strategies, and it's great to just know. But like Mrs. Nelson said, sometimes those numbers, what if it wasn't divided by 2? What if it was divided by 36 hundredths? What if it was divided by 2 and 27 thousandths? Then I have to go to a strategy versus just kind of seeing it. Questions, comments, wonderings? One to the word problem, Mrs. Nelson?
I would love to do that word problem. I don't know if we have enough time, but I think we do. We have it written, right?
Oh, it's written. It's written.
Yeah, I want to see. I want to see what these guys can do with this problem. Everybody put on your thinking caps.
Maybe I wrote a little. I think I wrote a little. Looked big at the time. Okay. Rebecca has 17 $1 bills. Courtney has 350 nickels. And the question is, do they have the same amount of money?
Draw a pause sign. All right, you guys. Is $17 equal to 300 nickels?
And instead of saying the is, we would put the question mark, right? Is this true? $17 equal this. What would we do? How would we figure it out? What would we need to know? How would we proceed? Tell me what to do.
So it's a 50-50 yes or no chance.
Well, there you go.
But
Except
I'm not that big a gambler. So
I got $15 and someone wants to trade it for 350 nickels. I want to know for sure I am making a good deal. So I either want to make an even trade and help somebody out because they wanted the dollars and I don't mind the nickels, but I certainly want to make sure I'm not giving them any money because money's money.
I would draw a picture.
Okay, so 300, first of all, we're going to thinking about what 350 nickels. What would you draw, Ms. Nelson?
Well, I know that there are 20 nickels in $1.
Okay, so if I draw it as 5 cents as a nickel, because I cannot draw George Washington.
That's okay.
If I had 20 times 20, I would get a $1 bill.
Yeah. And so I used to roll money with my dad when I was little. And I also know that each roll of nickels would have $2 in it. So when I see 350 nickels, I'm thinking about how many rolls I can make. So if I take my 350, I could just draw. How many would I draw? Let's see. Okay, so I'm drawing my picture. So each dollar is 200. So how many nickels would that be? 20. So 20 goes into 350 how many times? I would probably do 40. How many times does 40 go into 350? Would you divide 40 into 350?
350 divided by 40, right? I want to know how many 40s are
Yeah.
in.
Yes. So that's going to be $2. It's a complicated, but so is that going to be 7, 8, 8, 8, 8 times 40, 8 times 40?
8 times 0, 8 times 4, 8, 16, 24, 32, 30. Okay, and then
Oh, so that's like 8 times 2. So that's like $16 and
so 8 rolls. which is equal to $16.
Yeah.
I
And then
have
we got,
for another $2, but it's 17. Do I have enough for another dollar?
$1, a little more, because 20 is $1.
So I have
17.
20 is $1. So
So,
that I have 17. I have a greater than 17, right? I have a little bit more money than
yeah,
17.
I have greater than 17. So I know that those are not equal. And I knew it just from looking at it because I know rolled money, right? So that's the reason why I would solve it that way.
Took the approach of nickels to dollars. I'd have gone the other way.
I converted it. I used conversion. Oh, you were going to convert that to nickels?
I converted this to nickels because, again, I know that each dollar is 20 nickels. It's 20 nickels. So 17 times 20 will tell me how many nickels I have. So 0, 0 around, and then we're going to put a 0 here. 7, 14, carrying my 1, 2, 3. So 340 nickels. I only have 340 nickels, and you have 350. I like thinking. Your thinking was more fun, but I couldn't think that way. So I had to go this way. But
Another thing that you could do is you could just notice that 350, if there's groups of 20, doesn't go into evenly.
like your thinking, Parker, because it didn't ask who had more money, did it?
No, it just said who's.
You said, is it equal? Mm-hmm.
Nelson and I did, we could have told you who had more. It just says, is it equal? And you're going, because I already know 20 does not have an even number. 20 times X, 350. And I know that X wouldn't be a whole number, right? X is not equal to a whole number. I like your thinking. And I was trying to think of how to write what you were telling me in math symbols.
Because 20 doesn't go into 50.
Oh my gosh, I would have never thought of that.
That was that, Parker, is what we call in math a more elegant solution.
Yes.
We solved it each a different way, but yours was much more elegant. Why? Because it was simpler. So we call it elegant. It was like, oh my gosh.
Yeah, as long as you can show it mathematically with a model like that, that is, write that, an elegant solution. I love that. Diego, did you have a different way? Did anybody else have a different way that they did it? And so that gives us also that, you know, the ability to write it with the inequality too, right? So it does not equal. So when we use inequalities, remember those are equal is equal, but then we have the does not equal sign, we have the less than, the greater than, we have less than and equal to, and less than and greater than.
Well, that's all I needed to write for yours, Parker. 350 divided by 20 is not 17. You know it's not possible. So you already knew it was there.
All right, and that is how we use algebraic expressions to solve real world problems.